Hey guys, welcome to the spring Teks test review. Let's get started on the first one. So it says complete the table below by identifying the maximum or minimum points, if one exists, domain range of the given functions. Alright, so the first one here we have a square root parent function. Alright, so here let me graph it real quick and then we can see it. Square root. Alright, so here we could see that there's a minimum point at 0, 0. Alright, then for the domain, that would be bracket 0 to infinity. Again, we use a bracket because the 0 is included. Same thing with the range, 0 to infinity. Alright, next one, we still have a square root function. Alright, but this one's reflected over the x, so it's upside down. The vertex or the starting point would be at -3, -5. But on this one, it's not a minimum point. It's the highest point on the function, so it's a max. Alright, it's a max point. And then for the domain, we would go from -3 to infinity. And then for the range, your graph is upside down, so it starts with -infinity and stops at -5. Alright, so then for this next one, we have a cubic function. It has a vertex at, or not a vertex, so here, let me erase this real quick. So with cubic functions, they have a point of inflection. So here, let's look at the graph. Alright, so here the point of inflection is at 4, 2, but it's not a maximum or a minimum. It's not the highest point on the function, not the lowest point. So there's not a maximum or a minimum, but there is a point of inflection which would be at 4, 2. Right, point of inflection. I wrote that kind of bad, but right, again, just point of inflection. That's just where it changes direction. Point of inflection. Right, and then for cubic and cube root functions, the domain is always the same. It's all real numbers, or -infinity to infinity. All right, the next one's a cube root function. You guys, you got to remember this. Cube roots. In the calculator, you get it with math 4. All right, let me do that again. Math 4. Why am I going to the table? We'll just go to the graph. And then, same thing like cubic. There's not a maximum or a minimum point, but there is a point of inflection. And then domain and range, same thing, all real numbers. All right, same thing as -infinity to infinity. All right, those are the same thing. Then for number 2, if two graphs are inverses of each other, which statement is true? All right, so here, let me just give you all an example of some inverses. Let's see. Here, let's do math 4x. So for example, these two functions are inverses. They reflect over the line just y equals x. Here you can see it. So that's true. The values of x and y are interchangeable. That's true. All right, so for example, here you have 8, 2. So then for the other function, you should have a point at 2, 8. All right, right there. So again, these are interchangeable. Same thing with the domain and range, interchangeable. So this is all the above. All right, square root functions, we just kind of did that on the one up here. The domain and range is 0 to infinity, 0 to infinity for the parent function. The y-intercept is actually at the same point where the maximum and minimum point is. All right, so again, x and y-intercept is at 0, 0. Same with the minimum point, and there's no maximum. All right, for the cube root one, again, math 4, x, all right, domain and range for cube root is always all real numbers, or negative infinity to infinity. All right, the y-intercept is at 0, 0. Same with the x-intercept. We can see it right there. And again, no max or min point. Right, then for the bottom, right, on number 5, determine the type of function graphed, then state the domain range of each. All right, so looking at this function, I know it's a square root function. The domain is from negative 2 to infinity. It's upside down, so the range starts with negative infinity and then stops at negative 5. And then for B, this one's a cube root function. The domain is all real numbers. Range is all real numbers. C, function's cubic. Same thing, domain and range is all real numbers. Alright, so then let's go to solving. And if I want to solve this, I would just do negative square root of x equals negative 3. So I subtracted 3. Divide by negative 1. I get the square root of x equals 3. Square both sides. X equals 9. Same thing here. Subtract 9. I get 2. Square both sides. We get 4x plus 8 equals 4. Subtract 8, you get negative 4, divide by 4, x equals negative 1. Alright, then on C, this is a cube root, so you want to get rid of the cube root by cubing. Alright, we get x minus 2 equals 8. Add 2, you get x equals 10. On this one, add 11. When you add 11, you get 8, and then cube both sides. 8 cubed is 512. Subtract the 4. I get x equals 508. E, go ahead and cube both sides. I get 3x plus 1 equals, let's see, 4 cubed is 64. Subtract 1, you get 63. Divide by 3, you get 21. Alright, then for 7, this one is find the inverse of each function. Alright, on the table it's easy, just switch the x and y's. Alright, for B, first step is to always, again, switch the x and y. This becomes x, this becomes y. I'm going to add 11. I'm going to square both sides. Then I'm going to subtract 8. Alright, so my inverse is x plus 11 squared minus 8. And then it says if we have a domain restriction. Alright, so let's check. So I have square root of x plus 8 minus 11. X plus 11 squared minus 8. Let me change the window real quick so we can see it. So window, see if this looks better. There we go. So the original one is the square root function. When you find the inverse of the square root function, it makes a whole quadratic parabola. But if this is going to be considered the inverse, it should make the same kind of graph as this one. It shouldn't be a whole parabola. So we have to restrict this. So in this case, we just want to restrict it to the right side. So here, if I draw the line y equals x, if I reflect it over, it's going to be just this right side. So if the vertex is at negative 11, negative 8, the domain has to be from negative 11 to infinity to just consider the right side. Alright, then on C, same thing, switch the x and y. Alright, so I squared rooted, need plus or minus square root of x plus 5. Subtract the 1. And then for the domain restriction, just since I put that plus or minus, there's going to be no domain restriction. Alright, so when I find the inverse, or we already found the inverse, but when we graph it, it makes a whole parabola. Alright, so here I don't need a domain restriction, so that's good. Alright, then on this one, it's a linear function. Here, this one's easy. Just add 3, divide by 2. And I for sure don't need a restriction on this one. Alright. Number 8, which function is equivalent to its inverse? I will go ahead and do it. So x equals y minus 3 over 3 times 3, you get 3x equals y minus 3. Add 3. Alright, that's the inverse. This one isn't equivalent to this. Alright, so that's not equivalent. This next one, same thing, just subtract 5. Those aren't equivalent. I divide by negative 1, I get negative x plus 2. These are actually equivalent. So this is actually the same thing as this, they're just rearranged. Like if I were to rearrange negative x plus 2, it's just 2 minus x. So these are the This one is the one that's equivalent to its inverse. All right, then 9, this one's a composition. So 2, here, all right, so it's saying f goes into g. So this is going into this one. 2x minus 7 plus 7 over 2. Those cancel, equals x. That's good. All right, same thing, but g is going into f. 2's cancel first, then your 7's equals x. So yes, these are inverses. All right, then for 10, the time it takes a pendulum to swing back and forth is called the period of the pendulum and is defined by the equation t equals 2 pi square root of 11 over 32, where t is the period measured in seconds and L is the length of the pendulum measured in feet. What is the approximate period t of the pendulum if the length is 3.25? That one just plug it straight into the calculator. So about 2. What is that? 2. I guess I just put 2 seconds. Alright, then for B, what is the approximate range for the situation? Situation's function, the pendulum's length is limited to 10 feet. Alright, so if it's limited to 10 feet. And then if it was 0, it's 0. Alright, so if it's limited to 10 feet at 0, it's 0 seconds, and then 3.51 seconds for 10 feet. Alright, then for number 11, solve the equation. Jerome entered y1 square root of x plus 5, y2 equals 2 into the graphing calculator. The results from these entries are shown at right. According to the graph, what is the solution? All right, so you could always go to the table and see where they both match, but on the graph you could see that it's going to be negative 1, 2. X equals negative 1. Or, so either one. All right, then for 12, the graph of f of x equals x cubed plus 1, g of x is shown. Describe how f of x can be transformed to g of x. Alright, so based off the point of inflections, this one's just going right 4. What type of functions are these? Cubic. What's the equation of the inverse? So set the function equal to, or switch the x and y, then subtract the 1, and then cube root. Right. And then for number 13, right, this one's a exponential function. So exponential functions only have horizontal asymptotes. So y equals 1. Alright, the domain is all real numbers. Graph it, and then you'll see the range is from, or no, bracket parentheses, 1 to infinity. Alright, this one's a log function. We have vertical asymptotes. So x equals negative 4. Range is negative infinity to infinity. Graph it, domain would be negative 4 to infinity. Alright, so here, just so we could see it. Negative ln x plus 4 minus 3 Alright, so the vertical asymptote would end up being somewhere here, or it will be at negative 4. Alright, this one we just had a test on it, the rat fun functions. So it has a vertical asymptote at x equals negative 8, horizontal asymptote at y equals 5. Range is all real numbers, x cannot equal negative 8. Range all real numbers, y cannot equal 5. Alright, so again, main thing is knowing the difference. Exponentials only have horizontal asymptotes, logs have vertical asymptotes, rational functions have both. Alright, then for number 14, answer the following question for the function 3 of power of x plus 1. Alright, so what is the asymptote? Alright, so we just said it, this is exponential, so it has a horizontal asymptote, so y equals 1. It's an HA. Alright, what's the domain and range? Alright, for domain, it's all real numbers. And then for the range, if you graph the function, it would be at 1, no bracket, should be a parentheses, 1 to infinity. Alright, then for C, circle the value of the table shown where the solution f of x equals 82. There. And find the inverse. Alright, and then number 15. Alright, for number 15, the population of the town Numberville is currently 12,500 and is declining at a rate of 3% per year. Alright, this is declining, so this is a decay factor, or a decay situation. So if it's decay, we're going to use a 1 minus r to the power of t. If it was a growth, you would use plus. But for this one, it's declining, so use minus. Alright, so let's set this up. Y equals... or I could use, let's use P of t, just so I could be consistent. So P of t, it's same as y, equals the initial 1 minus the rate, which is 0.03 to the power of t. Then use your function to approximate the population in 5 years. So in 5 years, we got 10,734. Right, and then what is the approximate range of the population between 10 and 20 years from now? Alright, so remember, write these in numeric order. So since it's declining, I'm going to put the population for 20 years first. It's 6798. And then in 10 years, 9218. And then it says, in how many years will the population become half its current size? Alright, so let's see. Alright, so half would be 62,500. Somewhere between 22 and 23 years. All right, question 16. Moneybags has 1 million. He wants to give away. Each day he gives away half of the money to a different charity. How many days will be taken before he is down $15.26 down to? All right, so we start off with $1 million. The decay factor, growth factor would be 1/2 power of t. So just we can see it starts with 1 million and then just keeps getting cut down. Alright, so day 16, or 16 days. Right, and then for A and B, it's just conversion. So 3 to the power of x equals 5. Remember, it's b to the e equals a and log b. Alright, so this would become log, base is 3, arguments 5 equals x. For this one, go to exponential form, base is x, exponent is 3.4 equals 9. Right, 18. Right, when you're solving a log function, convert it back to exponential. Okay, this one's easy. What to the power of 3 to the power of what makes 27? X equals 3. Same thing on this one. What squared makes 9? X equals 3. And then for this one, it already sets up to where it's equal to x, so just plug it straight into the calculator. 125. Alright, and then for number 6, you want to get the same base for each one. So I'm going to use 5 squared and 5 cubed. Power rule, multiply those. Drop your bases. Add 2, divide by 2. Right, then for f, this 1/3, go ahead and flip it. So I'm going to use a base of 3, so this becomes 3 squared. And then this is going to become 3 to the negative 1 to the x. Right, and multiply those. All right, drop them. We got 2x minus 12 equals negative x. And then I'm going to subtract 2x, make negative 3x, and then divide by negative 3. X equals 4. And then do the exact same thing on number 9. All right, 2 to the 4, x plus 1, 2 to the negative 1, 3x. I want to get the same base, multiply my exponents. Drop my 2's. Add 3x, we got 7x plus 4 equals 0. And then when you solve it, you get x equals negative 4 over 7. All right, and then number 19, this one's a log function. Guys, log functions, the range is always all real numbers, negative infinity to infinity. What is the solution when log base 3 of x plus 1 equals 4? So it's saying when this is 4, what's the solution? 80. And then what is the inverse? Let's solve it. Switch x and y. Guys, from here I can't move anything. You also got to remember the inverse of a log is an exponent, so you have to convert it back to exponential. Base is 3. Exponent's x equals y plus 1. Now just subtract 1. Guys, and then for 20, just plug in with the calculator, see which ones have the same one. I'm gonna skip to 21. All right, so for 21, you want to find what type of function is represented for each table. All right, so let's look at this one. If I want to get from 14 to 9, I have to subtract 5. 9 to 6, subtract 3. 6 to 5, subtract 1. 5 to 6, add 1. 6 to 9, add 3. Alright, and then that's the first difference. Nothing really happens. And then let's check the second one. Negative 5 to negative 3, you add 2, add 2, add 2, add 2. Alright, that's showing me that this is going to be a quadratic function. All right, let's do the same thing for the next one. All right, negative 6 to negative 5, you add 1. Here you add 1. Negative 4 to 3, you add 7. 3 to 22, add 19. All right, second difference. Plus 0, plus 6, plus 12. Third difference. Plus 6, plus 12. This is the third one, so cubic. Alright, and then for the next one, it's all just plus 0.5 for all of them. Linear. It's a linear function. Right, now for this one, if I were to do the same thing I did on these, let's see what happens. All right, I would get 2.5, 5, 10, 20, 40. Second difference, 2.5, 5, 10, 20. Third time, 2.5, 5, 10. All right, so it's neither one of those three. But I do know that this graph, the y values double. Because they double, my x's are kind of going in order, or are going in order. I know this is going to be an exponential function. All right, so exponential. Okay. All right, then for 22, we just had a test again also on this. Vertical asymptote is at -2. The only one that has that is B. Again, you can just always graph them. So for example, this other one, 2 plus here we can see it. So the one that goes with that one would be C. Right? All right, 24 is just the asymptotes. Vertical asymptote is x equals -4. Horizontal asymptote is y equals 0. Same thing on this one. Horizontal asymptote is -1 because you went right 1. Horizontal asymptote is up 5, so y equals 5. Right, then for the long division, right, what times x makes x? 1. 1 times this makes x minus 3. Change your signs. I get 2. Right, so this would be 2 over x minus 3 plus 1. Same thing on this one. 3x minus 6. All right, 26 is an inverse variation problem. All right, so it says the time it takes Karen to drive a certain distance varies inversely as the average speed r. It takes Karen 5 hours to travel between two cities at 60 miles per hour. How long would the drive take at 50 miles per hour? All right, so we got hours, miles per hour. So 5 hours, 60, 50 miles per hour, how much? All right, so let's find the k value first. X times y, 5 times 60, 300. All right, so let's figure this out. So I would do 300 divided by 50, and I get 6 hours. Then for 27, Anna plans to rent a banquet hall for a party and has narrowed down her search to 2 banquet facilities. Viva Banquet Hall charges $135 for the rental plus $16 for dinner for each person. Which of the following functions models CX, the resulting average cost per person? Circle 1. All right, so the thing tied to a change is this $16. Depending on how many people come, this price changes. All right, so that one's tied to a rate, so it has to be something with 16x, and that's the only one that has that is A. All right, 135 for the hall, 16 times the number of people going, divided by the number of people going. So that'll help you figure out the total cost per person. All right, so then for the next one, Romero's Banquet charges 1 fee for the facility and guest. Anna expects 50 people to attend her party, and she calculates the cost per person at Romero's would be $20. So just do 20 divided by 40. There's only 1 fee, 40 people, $20 for that 1 fee. Together that makes $800. All right, so let's do the same thing. Let's use 40 people. All right, so here we got 135 plus 16 times 40 over 40. All right, we get 19.375 for the cost per person. If I multiply that by 40, we get 775. So based off those two numbers, I know Viva is the best choice. All right, so let's go to the last page. You guys, back page, these are all the 6 functions we did this school year. This page just wants you to fill the table out with the function with these corresponding transformations. So it's square root function. If I want to go left 5, I need y equals square root of x plus 5 inside the square root. If I want to go up in units, I need plus n on the outside. If I want to reflect, all we need is a negative in front of the square root of x. And then if I want to go down 6, right 2, we need square root of x minus 2 minus 6. Right, that one, same thing, x cubed plus n, reflect, just put a negative. This one's the weird one, the exponential one, because if you want to go left 5, you need x plus 5 with the exponent, so just remember that. Reflect, it's negative in the front. So here, if I want to go right 2, minus 2 up here, then minus 6 to go down 6. Expand by 5. Same thing with the log function. Alright guys, so make sure you study this, and good luck on your test. Don't forget to like and subscribe. Alright, good luck.